Okay, today is 10.2, day 2, and today we're mostly talking about bearings. So the lost puppy problem is going to require that you understand bearings. So if I were to ask you, where is west 20 degrees north? Is that what I asked you before? Okay, good. Would you have drawn it here first? There's west. Could that be a reasonable place to start? Okay. But then from there, I've got to sweep 20 degrees north of that. So boom, there's my right triangle. That's 20 degrees. Raise your hand if you had that one right. Okay, good. Now, that's totally different than if I had done this with true bearings. This is the ray in question. What would it have been with true bearings? By the way, on true bearings, you don't say north, south, east, or west. You just give a degree. 290. Do you get how that happened? Because it goes around to 180, 270, plus 20 more is 290. So 290 would be its true bearing. Raise your hand if you understand that. Okay, good. Then, now, if this is the problem that we have set up, I'll give you a really easy one. It was a boat in the middle of the ocean, and he started here, and he ends up here. And he went for 4 miles. How far north is he of his previous position? Now you might be thinking, well, you said he went 4 miles. He got to be 4 miles north. No, not 4 miles north. He's 4 miles away from his old position, but how far north of his position is he? So, and how did you get this side right here? Sine of 20 is what? Which is the question mark over what's the hypotenuse? 4, because I told you that was 4. Very good. So basically take sine 20 and then multiply it by 4. Raise your hand if you think you could handle that. Okay, good. So what's different about today's? Today's, they don't just give you an angle and a side directly. In the scrappy problem, it looks like this. I'd like you to sketch this on your graph paper. You can look at mine from here so you don't have to be like flipping back and forth. It says he runs south 60 degrees east, which means you were going south, then you swing 60 degrees east, and then you head that way. So do you get how I know this is 60? But this is critical. Listen, listen. This is really important. Always start these problems and end these problems on lattice points. Do you get that's a spot on the graph paper where the 2 lines cross? Start your line there and keep going until you hit another lattice point. Because the length of your line really doesn't matter. You can pick the scale of your map, so to speak. As long as you're going at approximately 60 degrees, just keep going until you hit another lattice point. Why? Because the angles at a lattice point give you nice 90-degree angles as references to see, okay, well, this whole thing's 90, but this angle right here is clearly less than 90. Anyway, so you need lattice points on each end. You need one here, you need one here. Because now you'll be able to draw some triangles around this green triangle, because this green triangle alone, all by itself, cannot answer the question. Even if you divide it up in little pieces, that green triangle will not answer all your problems. Who can see the other triangle that we will need to involve to make this work? Yes, sir. Come up and draw it. That's the triangle that we needed. Very good. I had a student come up and draw it. But wait a minute. That's a triangle where I know a side and an angle. So can't that just answer my question directly? No. What's the actual question? Find Scrappy's distance and bearings from home. Which of these lines is that? The blue dotted one. That's his distance from home. One more question I get a lot is, what does northwest mean? Well, I think you know it's between north and west. But if you were going to say it the way we usually say it, how would you say northwest with a compass rose? How many degrees is that? What? North of what or whatever? Northwest. Do you agree this is the angle we're talking about? And what is that called then? Should we call it west 45 north? I agree. That's west 45 north. Okay, so that means this angle right here is a 45-degree angle, but that doesn't mean that the red angle, this angle here, that's not 45. This is 45. And this whole thing would be 45. All right, so we've got some challenges to work out. This is not a super easy question, but I will tell you that you'll need to draw a triangle outside it, which I already showed you, and you knew this was 60, and you can find the blue dotted line. It's not impossible, but it might take you a few minutes. All right? I'd like to give you a few people to work with. I have an ulterior motive on this, 2 of them. Number 1, it's kind of a hard question. A lot of kids tend to get stuck and then they don't know what to do and they have no other ideas bouncing around in their head, so that when you work in a group, sometimes you get more people with more ideas. Number 2 thing is, one of the number 1 things that employers, like, you're going to go be an engineer someday or a doctor someday, one of the number 1 things that they want from us is that you can work with other people. You might think you're going to find a job where you just work completely alone. There's a few of those, but there's only a few. There's like a 95% chance you're going to be working with other people. So if you can't do that, because you don't get to pick who you work with either. It's not like a big company and you can go with, I'm going to work with Susie and Jane because they're my friends. No, you get stuck with Jim Bob and, you know, the doornail guy that you don't like at all. You got to learn to work with anybody who you get paired up with. So you happen to be in a room with generally a really good selection of smart kids, so it works out pretty well. But anyway, that's why I pair you up with people. It's not just because it'll help you answer this question. It's also because learning to work with other people is a skill, and it's one you can get better at. Okay, so right now I'm going to come around and cluster you in little groups, and I want you to not just, let's say one smart person figures it out. Cool, but you need to all write it down on your paper so that you can see how it gets done. Them telling you doesn't mean you understanding. It might take a few minutes between them telling you and you understanding. And hopefully it's kind of a group effort. All right, pause for a second while I get you in group. Okay, so we just summarized this. I forgot to record, but I'll remind everybody. Here's how you would have done it. We figured out these 2 sides, and once we knew those 2 sides, the angle between them is easy to find. This side was 1.06. And then this angle had to be 16 degrees, and therefore Scrappy's bearings from home is east, but then 16 degrees south of that. And here's his distance, 1.06. So according to this, he's going to sleep in the doghouse tonight because he's more than a mile from home. Okay, so moving on. The next thing we want to do is look at the homework problems for tonight. And we're starting with this one. And this was new to a lot of kids. They hadn't seen minutes. On your graphing calculator, would you please type in sine 68? And then I got to show you where the degree symbol is. Because if you put in 68.22, you'll be totally wrong. 68 degrees, there's a menu called the angle menu. That, of course, would help you type in angles, right? It's within the upper left-hand corner set of buttons. Look for the one above apps. Above apps, do you see where it says angle? Everybody do this on your calculator right now. You're typing in 68 with the little degree symbol, and then you type in 22 with the little hash mark. 22 hash mark. And what did you get? Did you get 0.929? Raise your hand if you got 0.929. Okay, good. Then you know how to enter them now. Do you get that would be the exact same thing as if we had said sine of 68 and 22/60ths? Because that's what they are. They're degrees, except divided by 60. So it's 22 minutes means 22/60ths of a degree. Is there questions about that? All right. So we need to now draw a picture for this situation. And I told you, let's see if you remembered this. Did anybody start by drawing a compass rose? Because that's how you should have started. Good. Now, from there, we got to go north 68, no, north, but then swing 68 degrees, 22 minutes to the west. Here's my swing. And it's 68, don't say 0.22, tempting, but that's 68 degrees, 22. I went east, thank you. All right, there's north, and west is this way. So it should be like that. Have I got it right now? Hold that thought a second. Okay, I do eventually need that angle, but it's not from the start. Sorry. It starts by heading northwest. So I need to go like that first. And that technically is north 45 degrees west. That means this is 45 and that's 45. After covering a distance of 16 kilometers, that implies to me that I should put a 16 on this. Then it heads in a direction of north. Okay, another compass rose. This is so important, guys. I can't overemphasize how important it is. You put another compass rose right there, because that really, really, really helps. Okay, from there, he's going to go north 68, 22 west. All right, so that's going to be this. Or from this compass rose, this is 68 degrees, 22 minutes. Find the ship's distance and bearing from its original location. So I do, in the end, want this to be a triangle. Let me think. 68 degrees. The way I drew that doesn't really look like about 70 degrees. I'm going to stretch it out a little further. It's probably more like that. And then the dotted line is what we want. And this is 68, 22. Okay. Not super easy. Once again, I've got a not right triangle. Once again, I'm probably going to drop a perpendicular down so I get two right triangles. I would bet you money that this is involved in this solution, right? It's happened like almost every time. But that doesn't necessarily just going to give us our answer. This compass rose I'm going to draw in blue. This is critical. Because that makes it into three angles. This one's 68. This one we don't know yet. And this one's 90. All right. Also, pro tip, draw them bigger than I drew it. Because now it's really hard for me to see all my angles. Another thought, I like to do them on graph paper because it has built-in compass roses. Okay, but you don't have to. Okay, but if you're having a challenge on a problem, write it big on graph paper and it helps. All right, not doing the whole problem for you. That's your job. Got to set up, though. I'm going to tell you to do number 11, do number 12, but then you may skip this 8-minute problem right here because the assignment was going to be a little too big. So skip number 13. And that was the last one. So, all right, and that's all I got for you for today.